Good morning, friends. My name is Vipin Agrawal, and today we will see our next topic, polynomial. So, what is the polynomial? We know an algebraic expression can be written as, for example, algebraic expression ax square plus bx plus c. Now, this is the general algebraic expression can be written in the form of single variable. Suppose it contains single variable is x and many more constants, for example a comma b comma c, these are the constants. Now this expression is an algebraic expression. Now we have to know what is polynomial. Polynomial can be expressed in the form of one variable, again f of x is equal to a0 plus a1 x plus a2 x raised to power 2 plus and so on, and the last term becomes an x raised to power n. Here we can see number of constants, for example a0, a1, a2 up to so on an. This constant a0, a1, a2 up to an are real numbers, means that number may be positive, negative or rational or any irrational form. But the index of x is x raised to power n. This is our index of x, which is always belongs to whole number, means n is an non-negative integer. N is always non-negative integer. This form of expression is known as polynomials, means this contains number of constants which may belongs to real number, and index of x is always belongs to whole number. Now, how will we identify any polynomial? So we see identification. Suppose we have one example, x square plus 3x minus 5. Now, first we apply definition of polynomials, means it contains constants which are belongs to real number. So it has, suppose coefficient of x is 1, coefficient of x square is 1, coefficient of x is 3, and constant is minus 5. So these are the constants which are belongs to real number, that is good. And power of x, here index of x is 2, which is also a whole number, hence this equation obey the definition of polynomial. Hence we can say that given equation means x square plus 3x minus 5 is our polynomial. Now second example we see. Now this example again contains constants which are real number, but here coefficient of x is 2, this is good, but here this is the power of x is 2, and here power of x means index of x is in the form of irrational number, is 1 by 2. 1 by 2 is a non-negative integer, hence this is not obey the definition of polynomial, and we can say that this equation is does not a equation of polynomial. Again we see one example. Suppose for example x square plus 5 into x raised to power minus 1 plus 3. Again apply definition of polynomial. First, coefficient of x is 1, here 5 and 3 are the real numbers, and index of x is 2, and here index of x is minus 1. Our definition is n is an non-negative integer, but here n is negative, hence this is does not example of polynomials. Got this? Then next we see degree of polynomial. Degree of polynomial. Now in our equation, then we write one equation, suppose polynomial equation f of x is equal to a0 plus a1 x plus a2 x square, and last term becomes is an x raised to power n. Here highest index of x is n. This represents the degree of polynomial. Its definition is highest index of x represents degree of polynomial. Now we see one example. For example, 3x square minus 2x plus 5. Now this is a polynomial by the definition, and it contains highest index of x is 2. Hence we can say that degree of that equation of that polynomial is 2. Again we see one more example. Suppose 5 plus 3x minus 2x square plus 7x cube. Now again by definition of degree of polynomial, highest degree of x, highest index of x is 3. Hence we can say that degree of polynomial is 3. Now polynomials can be classified as two types, or we can say that polynomial contain two types based on degree. So we can draw one general graph. It contains two types based on degree and based on terms. Means in that case we have to count total number of terms in the equation, and we give a proper name of a particular term. So based on degree, we define first polynomial is 0 degree polynomial. What is in 0 degree polynomial? We know that degree of polynomial, if maximum degree of x is 0, we can say that this polynomial is 0 degree polynomial. 0 degree polynomial. For example, 5 x raised to power 0, or we can simply say that 5x raised to power 0 can be written as 5. Now here degree of x is 0, hence we can say that is a 0 degree polynomial. Or we know that by indices any function or any constant power 0 is known as 1. So 5 into 1 we get 5. This 5 is the constant term. So we can say that any constant term or any constant function or any constant number is a 0 degree polynomial. Next type is linear polynomial. Linear polynomial. In this polynomial, the degree of x, in this polynomial, the degree of x is 1. Degree of x is, that is degree is 1. For example, 5x plus 2. We know that here degree is nothing, means 1. So 5x plus 2 is an example of linear polynomial, or something we can say that 3x minus 5. This is also an example of linear polynomial. Then next is quadratic polynomial. Quadratic polynomial. In this, degree of polynomial is 2, or we can say that degree is, for example, x square plus 3x plus 2. In highest index is 2, and we can say that this is a quadratic polynomial. Next is cubic polynomial. Cubic polynomial. In this polynomial, highest degree of x is 3, and this polynomial is known as cubic polynomial. For example, 3x cube plus 5x and something, suppose plus 2. We can say that in this example, highest index of x is 3, hence this is the known as cubic polynomial. And last one is biquadratic polynomial. Biquadratic polynomial, or second name was quartic polynomial. Second name was quartic polynomial. In this polynomial, highest degree of x is 4. Again we see one example, 3x raised to power 4 plus 5x minus 2. So this is the classification based on degrees. We can see 0 degree polynomial. In this polynomial, higher degree of x is 0, or we can say that any constant term is a 0 degree polynomial. Then linear polynomial, in this degree is 1, for example 5x plus 2, higher degree of x is 1. Then quadratic polynomial, degree is 2, higher degree is 2, hence with, for example, x square plus 3x plus 2. Then cubic polynomial, degree is 3, or we can say that example 3x cube plus 5x plus 2. In this example, higher degree of x is 3. And next is quadratic polynomial, or we can say that quadratic polynomial, here degree is 4, example 3x raised to power 4 plus 5x minus 2. Now rest classification based on the terms. Now we classify as, now first classification is monomial. Mono, what is the meaning of mono? Mono means single term. Mono means single term, means only one term we known as a polynomial, monomial. For example, x is only in single term, x is a single term, or 3x square is also an example of monomial, or suppose 5x cube is also single term, or any constant term also, for example 2 is an example of monomials. But 2 plus 3 is also a monomial, because 2 plus 3 is a 5, and 2 and 3 are not different terms. We can add each other, we get result 5, hence we can say that 5 is a monomial. Second, binomial. Binomials means it contains only two terms. Bi means 2. It contains two terms, for example x square plus 2, or x minus 3, or x raised to power 4 plus 3. This is an example of binomial. But we cannot say that 3x plus x is a binomial. 3x plus x is a binomial because 3x plus x equals 4x, and 4x is a monomial. Third, next one is trinomial. Tri means 3 terms, so it contains 3 terms. For example, x square plus x plus 2, or x cube minus x minus 2. Now these are the example of trinomial. And furthermore, terms means more than 3 terms, we generally say as it is a polynomial. More than 3 terms are generally known as polynomial. More than 3 terms. Examples are, we can say in example cubic polynomial x cube plus 3x square plus 2x plus 1. This is an example of polynomial. So today we will see general definition of polynomials, then definition of polynomials, then classification based on degree, based on terms, examples. Next time we will see general identities that are used in polynomials, value form, and based on examples.